Hey everybody, thank you for the introduction. I'm Alex Fisher. I'm an assistant professor of the practice here at Duke Statistical Science, and it's my pleasure to talk with you today. My honor to be here and tell you a little bit about reproducible pedagogy with R and Quarto. So first off, why reproducible? We're all familiar with comics like this, with illustrations of the importance of reproducibility in research. However, why would you want your classroom to be reproducible? Why bother in teaching? Well, in teaching, uh, with reproducibility in mind, we really have two audiences. The first is students, but the other is instructors. First, addressing students, there's something called the role model effect, right? If I'm telling my students, hey, it's important to do reproducible research or to do reproducible homework assignments, etc., then it carries much more weight if I'm practicing what I preach. And if I can point to my own pedagogical materials and be an example. So in the classroom, everything we do is a role model for students, and reproducibility, in my opinion, starts in the classroom. The second audience of your reproducible teaching materials would be other instructors. So we all know from writing papers or from working on big projects that the best ideas are iterated upon. And when you make your teaching materials publicly available, put them out there for other people to use, or you go to a colleague and use their teaching materials, you often make them better, or other people make your ideas better. So that's the foundation ethos for this whole talk today. And on that note of reproducibility, if you'd like to find these slides, you'll find these slides, and then at the end, a brief tutorial on some of the things I talk about today at this URL / this QR code. With that being said, a brief outline of what I'm going to talk to you about today. I'm following up 3 awesome speakers who just gave you all sorts of highly technological tools to use with Quarto. I'm going to bring things back a little bit. I'm going to talk about basic things like fence divs, how to use them, how I use a number of really basic Quarto tools in my course, as well as a couple of different R packages. And I'm going to underline everything with real examples from a course I taught for the last few semesters here at Duke. It's Bayesian Methods in Modern Statistics. It's an introduction to Bayesian statistics targeted towards undergraduate students, and the class size is about 60 students. All right, so first off, some of the Quarto tools that I use. And I know many of you have seen this highlighted just a few minutes ago. Many of you have probably used it yourself. But they're my 2 absolute favorites that make their way into every single set of lecture notes. That's code folding and panel tab set. So as I've moved all of my notes to being online, LaTeX, on a course website, and trying to use real data-driven examples in the classroom, the biggest issue I've had with that is just getting your code out of the way, getting all of your information prominently visible with everything that is maybe auxiliary hidden. So I have this little drop-down menu here so you can see all of the different libraries that went into this lesson. Although I see, maybe I need to be over here to click. So I'm using tidyverse, LaTeX to expression to insert these nice thetas down there that you can possibly see if you're sitting towards the front, as well as glue and patchwork to make this beautiful plot. And what's this plot showing? This plot is showing the evolution of a posterior distribution of the probability of heads in a coin flip. Let me try to make this full screen to avoid the cutoff. So what we see here at first is our flat prior beliefs. When we have n equals 0 coin flips, no data, we have a uniform prior over the probability that the coin will land heads. After we see 1 coin flip, it clearly lands heads, and now the probability of it being a double-sided head coin goes to 0. After 2 coin flips, we've now seen a tails, and so the probability of it being double-sided either way goes to 0, and so on. The coin evolves. And you might have another example you want to use to introduce the ideas of a posterior distribution evolving as you collect more data. Students might have a use, be it on a future homework assignment or research project they do or future job to recreate a plot like this or want to um, augment this in a different way. And so I use these panel tab sets to have a, whoops, remember to click over here. Use these panel tab sets to have all of the code to recreate each plot that I show in class for this purpose. Another big one that I love to use are these callout chunks. So no doubt you've seen these if you've been using Quarto for a while. Oops. But these are great. These are actual excerpts from class. I like to rename them. So I like to change my callout notes to definitions, include all important definitions. And then anytime there's something that I really want to grab the student's attention, I use the important notes or the important callouts. For example, reminding students that Markov chain Monte Carlo is not a model. All right, so all of this would be living on my own local machine, except for Quarto websites. So moving away from the learning management system hosted by your institution and developing a personal class website to host your course materials can be really nice, especially for being able to access the notes on the go. And if you haven't tried it out, I'd encourage you not to just fork my website or fork somebody's website, but really just play around with the basic features. It's really powerful and illuminating, and it's as simple as opening up in RStudio, file, new project, Quarto website. Now, there's three things that I really like to do that I didn't see the best tutorials surrounding online, so I put them here. One of which is hosting your data sets. So like I said a little bit earlier, I like to lead most lessons with some data example that sort of drives the narrative for the day. And all of those data sets can be hosted on the course webpage. So I just clicked on the link here, and there's this webpage that shows all of the course data sets, and you can click on one to instantly download it if you like. But did I have to go through and create some HTML document that links to every data set and name it, etc.? I did not. So in order to do this really easily, all you need is two components. First is in your Quarto YAML, you need to actually make sure you're hosting these files in the output folder of your Quarto website. To do that, you just add a simple, and I should have just mirrored screen here. I don't know why I have two screens and have to keep looking, right? But you just need this little line here, resources, and if the folder's name is data, you would put data there. Next, you need a blank Quarto file within the project directory with the following YAML added. Importantly, I have a section called listing, contents, and /data/*, the asterisk being the typical regular expression to say all contents in this folder. And you can sort them. You can sort them by title descending, you could sort them by date added, you could sort them however you want, and it will auto-generate a data page like that for you. So you can host all of your data in one place, such as my website /data. Another big tip I have, and again, I'm clicking in the wrong place, is downloadable R scripts. So if you have a script to do something, you can instantly share that on your website, make it downloadable, be able to click it. I have one embedded in this slide here. I call the automatic schedule maker. As you can see, I recently downloaded it to check that the link was working. But what this does is it creates a schedule like this. So this is the landing page for my website. It's a schedule of all topics with reading, assignments, etc. So you can click on an assignment or a lecture, and it gives you all the material. Try this. And what that automatic schedule maker looks like is it's this R file, in case you like to use, whoops. Technical difficulty. Trying to drag this over. Oh, because this is full screen. This is the fun of demoing things. I was actually really impressed by our last speaker, Colin, demoing live and everything went well. So great job. Okay, so this is what the file looks like should you choose to download it. It's just a $5 donation. No, I'm kidding. It's super easy to use. You just put in the dates that your class meets, when the first day of class is, when the last day of class is, when the lecture days are, when the lab days are. You run this, it outputs a table you can just copy and paste into your Quarto document. It's just regular Markdown. That generates our schedule page here. And finally, the last thing that I want to touch on with websites is the formatting of your course materials. So for example, on the course webpage, I have a course syllabus, and just by including this bit of YAML at the top, that has a call to both HTML and PDF. Students can download the notes or download the syllabus by clicking on the PDF format, easier printing, easy to have your notes in multiple versions thanks to Quarto's backend Pandoc that lets you render to different types of documents. All right, that's enough demoing for a little bit. On to R packages. And actually, my first R package is not only an R package, but now also an extension I understand you can use in Quarto, and that's Countdown. So one of my favorite pedagogical tools outside of using basic Quarto functionality with callouts and panel tab sets is this countdown function or countdown package. So students show up to class, and at the beginning of class or near the beginning of class, there's sometimes a random pop quiz that serves two purposes. One, to get students to review previous material, and two, to get them to show up to class, to incentivize actually being there, since I do record all my lectures and post them online. So what it looks like is this. You come to class, you have 3 minutes, 3 questions. You either know it or you don't. They're not meant to be ones that take a long time to think about. The countdown starts, everybody has a sheet of paper or a quarter of a sheet of paper, and we get right into a quiz. Now, out of curiosity, how many of you think that students like pop quizzes? Show of hands, not one? That's why I have this slide. I have a testimonial slide for you. So these are real testimonials, all from real students on my last course evals. I just Command F searched the word quiz, and there they are. So those are the ones that actually mentioned the word quiz. People actually like them. And I personally believe it's all because of the countdown package. So another package I really enjoy using in the classroom is the animate package. Again, I don't have a tutorial or anything on this, but what you're looking at here is an illustration of what it looks like to sample from a posterior and Bayesian regression. So in a regression problem you might be familiar with, we have y equals beta 0 plus beta 1x, maybe plus beta 2x for multiple regression. That's exactly what we have here. Actually, based on the axes, does anybody recognize the data set? Penguins, thank you. Yes, so this is, a class favorite. I should have included Allison Horst's drawings of the penguins here too. That would have brightened up the slide a little bit. But what you see here is actually sampling different values of these parameters. And as we move through parameter space and sample different values, it's useful to have this illustration of what's really going on. We're actually sampling different planes in 3 dimensions, or in higher dimensions, we would just be sampling some hyperplane. So these are some of the tools that I like to use in the classroom to give students the ability to interact with and feel the material and let most of the note-taking, let most of the handwriting issues, let most of the messy code being all interspersed within the notes get out of the way. And just briefly, I'll show you the last thing I'll demo, I promise, an example lesson. So I'm just going to click on one here of how this actually looks coming all together in the classroom. So here's one of the first few lessons from the course. This was on, what did I click on? Let me look at the URL. Poisson gamma model. So here teaching a Poisson gamma model. And I don't want to bombard students with all of the things that really are auxiliary to what's going on, like the packages being used, et cetera. So I just have at the top of most of these lessons, see the libraries if you want to reproduce this. But we jump right in with real data examples. So looking at data from Boston Celtics, we see the number of assists each player has in, I believe it's one game, but I'd have to go back and read what I wrote there. But not only that, students can interact with it. If they want to go back and replicate these things after the class or during class, they can go pull the data directly from the website by just copying this code chunk and jumping in and playing with things. You also see, as we move on, we start using some of these panel tab sets. We have a exercise together with a solution. We have plots plus the code to generate the plot. We have different notes highlighted to break up the monotony of reading the plain text, and I think you get the point. Finally, if you'd like to check out any of the material I've shown you from the Bayesian Methods course here at Duke, or fork the website, play around with it, you can, of course, access it on github.com at the URL provided here in the notes. And as a final parting gift, I have a few slides on tutorial that I won't go through directly. It's very basic stuff, that basically building off of Quarto documentation. But in case you wanted to plug any of this stuff into your course or materials today and wanted to play around with it, there's a brief how-to on the code folding, the panel tab sets, call-out chunks, using the countdown package directly instead of the extension in the back end of these slides. But that's all I have for you today. Thank you all for listening. And that's it.